Okay, so DC, the power is in one direction. It does not have a sine wave. It does not try to move anything. The DC motor has to have something called commutation. All right. In order for it to move, you have to make the magnets change polarity, change and go or go on and off. So in a DC motor, you have a rotor, and you have something called the commutator, which is a ring with segments that are hooked to coils in the rotor. So DC motor typically has wound rotor. So what happens is there's a brush that runs against that ring, and there's another one on the other side. And as the motor rotates, different coils are energized, and that's how it gets its the ability to turn. Okay. So there's magnet coils around the outside as well, just like any other motor. All right. Now, so if you're familiar with the power tools like pistol drills and things like that, and they have a cord on them, the way that these motors work, that they're called a series connected motor. What does that mean? Well, in a series motor, the outside winding is the field, and it's a coil, and then they put it through the brushes to the commutator and back out the other side, and then that goes to the other side of power. So they're in series. A series motor generates a tremendous amount of power for a very small motor. One of the things is that without a load, like if you take the motor out of a pistol drill and you didn't have any gears, the motor would throw itself apart from high speed. And in fact, in the first robotics, we're using motors that are series wound, and they run 25,000 RPM, a little tiny motor. They put out a lot of power. The problem is that because they're small, if you stall them, magic smoke comes out, and they're no good anymore. So series is real common for your power tools and stuff. Lots and lots of power in a very small motor. It makes it convenient for that. So then you go to that. Those are brush motors, and they also have permanent magnet motors, where the outer core, these become permanent magnets. So you don't have what they call field windings. You have permanent magnets. Still has to have brushes and a commutator, and this is pretty much the reason that DC motors have gone out of favor in industry. Is there's quite a bit of maintenance involved with the brushes and the commutators. Every so many thousand hours you have to pull the motors out, turn the commutators, replace the brushes and stuff like that. And so DC motors also did not, where the controls were way more complex than AC motors. So they pretty much went away. You still see them, but they're usually a throwback to a bygone era. So that's the two basic kinds of brushed motors, all right?